All right, so for today, we're going to start talking about our notes 5.3, known as the six trigonometric functions. So, yes, if you thought that you only had a friend named SOHCAHTOA that dealt with sine, cosine, and tangent, there's actually three more trig functions that we have to talk about. So, like I said, it's only going to get a little bit more interesting. And once again, welcome to Algebra 2, right? So, when we're looking at our triangles, so here's our reminder, right? When it comes to trigonometry, they cannot survive without a reference angle. So we need an acute angle in a triangle like we have here. And as always, this is the side that has no contact with that angle. That's why it's the opposite. The hypotenuse, of course, is always across from the 90. So there's the hypotenuse. And of course, the adjacent is the one that's right next to the reference angle that we're going to be working with. And so we have our adjacent side as well. So we're still going to do everything the same that we did before. In fact, notice when we say sine of theta, we're still going to go opposite over the height, right? So none of that has changed. When we talk about cosine, cosine is still the adjacent over the hypotenuse. And tangent, tangent is still the opposite over the adjacent. But I want you to notice something here when it comes to these new trig functions that we're going to be working with. The first one has the letters CSC. And no, it's not cosine, that's COS. But CSC does stand for one thing, and it stands for cosecant. Now, I like to call them, right, all these three new ones, I like to call them the flip cousins. I'm going to show you why I like to call them the flip cousins here. So sine is related to cosecant, and cosecant is what I've just called right now the flip cousin of sine. So cosecant and sine are related, and here's the reason. In order for me to find cosecant of theta, well, look at what they did. They said it's hypotenuse over the opposite. So if you notice, all they did was one thing. They flipped. All you have to do is flip the fraction, and you have the answer to this brand new trig function called cosecant. And the thing is, sine, cosine, tangent, they all have this cousin. So you see, when you look at cosine, same thing. As I head down, SEC, well, that's short for secant. Brand new trig function, never saw that in geometry. But notice, all we did once again is just take this original fraction and we flip it over. And then, of course, tangent does the same thing. Tangent, we're looking at this one right here, COT. Well, that's just for cotangent. So that stands for cotangent. And if you look at what cotangent is, all I have to do is flip whatever answer I already wrote for tangent. All I have to do once again is just flip the fraction. That's it. That's why we call them the flip cousin. Each one is related to one of the original trig functions that we've worked with. But then all I have to do is just, as soon as I have these three answers, well, then I just flip them over for the cousin. So the abbreviations opposite, adjacent, hypotenuse are often used to represent the side lengths of a right triangle. Note that the ratios in the second row are reciprocals of the ratios in the first row. And again, when they say the word reciprocal, that just means one thing in math. Flip the fraction, which is what we already mentioned. And so they do go by another special name here, of course. Cosecant is the same as 1 over sine theta. Secant is 1 over cosine. Cotangent is 1 over tangent. All they're telling me right here is to flip the fraction. See, they took sine, flipped it over. They took cosine, flipped it over. But the official name of these, I know I said I call them the flip cousins because we're literally flipping fractions. But here's the true name for these right here. This is what we call the reciprocal, because they were flipped, the reciprocal identities. An identity is just another way of saying like a formula. in math. So the reciprocal identities are these three right here, which just means we're going to flip them over. So the biggest thing you have to know is, all right, I have to know who's related to who. And the reason you want to know who's related to who is because you have to know who to flip. The good thing is, one thing to remember is, look, they never start with the same letter. That's the mistake. People think, oh, sine is related to secant because they both start with S. And that would be wrong. Okay, so be careful. All right, let's try these two problems right here. So it says evaluating trig functions. But remember, if this is my theta, yeah, they already told me who the hype is. This is the opposite. This is the adjacent. But we have a little bit of a problem. If you notice, they never really told me who the hypotenuse is. We don't have that number. But remember, in order for me to answer these kind of questions like we did previously, I know last week we were really only doing these three and that was it. We would move on. Well, now we're doing 6 of them. Not that it's more work. Well, technically you're writing more, but it's not difficult. So my only issue is I need to have that number. I already know this is 5, this is 12. And if all I'm missing is one side of a triangle, well, then of course, if I want to find the hypotenuse, I'm just going to write height for short. Well, then for a problem like this, I can use the Pythagorean theorem. So let's apply it. Let's see, my leg is 5 squared plus the other leg is 12 squared. What I'm looking for is the hypotenuse. We can just call it C like they do in the formula, right? We can put a C there if we needed to. 25 plus 144 is equal to C squared. I don't want to get in the way here, so I'm going to move it over. I'm going to combine my like terms like we did last week. 25 and 144 is 169 is equal to C squared. And here we go. Take a square root. And just like that, the C is equal to 13. We have now found our hypotenuse. So now we can actually put it in the picture. And there's the 13 that goes there. So here are my numbers. It's a 13, it's a 5, and it's a 12. All right, now let me show you how we do this, how I do this very quickly. I already have all my 3 numbers. I know I got a little messy. I have my 3 numbers there. And remember, all I did was use the Pythagorean theorem right there, right, to find the hypotenuse. So Pythagorean theorem. All right, well, look, forget these new ones for now. Let's stick to the original 3, right? If I bring in SOHCAHTOA, look, SOHCAHTOA is sine is opposite over hypotenuse. Cosine, CAH. And tangent is TOA, according to our friend SOHCAHTOA, right? We still bring that in. We still need it. So I'm going to answer all of these problems very quickly. I already have all my numbers. O, so that's 12 over the 13. There. This problem is done. All they said was give me a fraction. I don't do that cross multiplying, none of that. No inverse. Cosine of theta is AH. The A is 5. The H is 13. And then finally, tangent. Tangent is opposite over adjacent. Opposite over the adjacent. And just like that, we finish the original 3. And that's what you need to continue to do. To make this stuff easier, just continue to do that. Now we can talk about the cousins. Now, here they're lined up for you and ready to go. You see, related to sine is cosecant. And remember, they're called flip cousins for a reason. If this one says OH, well, then this one is HO. And so if it said 12 over 13, flip it. 13 over 12. And just like that, there's my answer for this one. That is why we call them flip cousins, but you have to know who's related to who. So the next one says, all right, well, if this one is cosine, I'm going to do secant. If this is A over H, well, then it's H over A. And if this one was 5 over 13, well, that means 13 over 5. And finally, last one here. Cosine was related to secant, so tangent is related to cotangent. And if this one is OA, well, then flip it, AO. My adjacent was 5. My opposite was 12. And there it is. Look, it's just the flip of 12 over 5. So that's what I'm saying. Even though we added 3 new trig functions, notice how I started with my original 3. Because as soon as I do my original 3 over here, all I have to do is just start flipping over for the others. So difficulty-wise, it shouldn't be too much. All right, one more to go on this page here. So again, they said evaluate the 6 trig functions. Yes, there's theta, even though it's kind of light there, but there's theta. They said this side is 7, this side is 24, but unfortunately, I'm missing the height. But wait a minute, we should have done this earlier too. Yeah, I can bring in my Pythagorean theorem, but remember what we said. Always check out the triples because you might have saved time. In fact, look, unfortunately, there was the 5, there was the 12, 5, 12. Look at that. We could have answered this question a long time ago without the Pythagorean theorem. It still worked, right? We got 13 also. So let's look at this one. There's a 7 and a 24. So if there's a 7 and a 24, yep, there it is. Look at that. 7, 24. That means the height has to be a 25. And this is how we save time here. We now know the height is 25. And what I applied here, I used the Pythagorean triple. And the Pythagorean triple that I used was the 7, 24, 25, and I just saved myself some time. Look at the work I did earlier, but because it's a triple, plenty of time saved. All right, so here we go again. Just like I mentioned earlier, we're gonna go with the basics here. I'm gonna label first. Here's my opposite. Here's my adjacent. And obviously here's the height. They already wrote that for me. I'll put the H anyways. All right, our friend SOHCAHTOA, everybody. S-O-H, cosine, C-A-H, tangent, T-O-A, according to our friend SOHCAHTOA. Now I'm just going to put the numbers where they belong. O first, so 24 over 25. 24, 25. I can't even reduce it, so that's good. Cosine, A-H, 7 over 25. Boom, perfect. Tangent, O over the A. O over the A. Just like that, we have the original 3, which now means I can answer all the flip cousins. Now, related to sine is cosecant. Okay, they're lined up again. So OH, well then that's HO, which is 24. Whoa, which is 25 over 24. Okay. AH, well then that's HA. So then all I have to do is flip this one, 25 over 7. And finally, looking at this last one, tangent is related to cotangent. Flip it over, so 7 over 24. And just like that, there's my answer. So you have a couple problems like this in your warm-up as well. Sorry, not your warm-up, your classwork. So we might be able to pause shortly. I know there's a couple you tries, but for now, we're going to leave it at this point for this video.